Good afternoon to all. Myself, B. Ramesh, Assistant Professor, Department of Triple E. Today, I'm going to explain power quality issue. So before that, what is the power quality? So there are different definitions for the power quality. The first one is any power problem manifested in voltage, current, or frequency deviation that results in mainly misoperation or failure of the customer equipment. So this power quality is equal to the voltage quality. Why? Because the utility can control only the quality of the voltage. It has no control over the current because that particular loads might drop. So therefore, the standards in the power quality area are devoted to maintaining the supply voltage within the minimum certain limits. Next, power quality evaluation problems evaluation. So it consists five states. First one, identify the problem category. So here some of the problems we have to identify. For example, voltage regulation or unbalanced, voltage sag, interruption, flickers, transient, harmonic. So one of the problems we have to identify. Next, problem characterization. So in this stage, how to collect the measurements and data collection. So here, what are the causes? Next, characteristics and equipment impact has been collected. Next, identify the range of solution. So in third stage, we have to identify the where the range of solution. So for example, it may be utility transmission system, utility distribution system, end user customer interface, or end user customer system. Otherwise, equipment design and specification. Next, fourth step, evaluate the solution. So by applying the modeling analysis procedure, evaluate the technical alternatives. Finally, optimum solution have to apply that evaluates the economics of possible solution. Next, classification of power quality issues. So power quality issues may be the transient, long duration voltage variation, short duration voltage variation. Long duration voltage variations again classified into over voltage, under voltage, and interruption. Short duration voltage variations consist of sag, cell, and sustain. Interruption, voltage imbalance. So these are the some of the problems. First one is the transient. So transients are majorly two types. One is the impulsive transient, another one is the oscillative transient. So impulsive transient is the sudden non-power frequency change in the steady state condition of voltage, current, or both. But the impulsive transient is having only unidirectional in polarity. That may be this transient exists in either positive or negative half cycle. Yes. There is the sudden non-power frequency change in the steady state condition of voltage, current, or both. It consists in only one direction, that is unidirectional in polarity. The major cause for this impulsive transient is the light. Next, oscillative transient. So oscillative transient is also a sudden non-power frequency change in the steady state condition of voltage, current, or frequency. Voltage, current, or both, but it has both the directions. It consists of both the directions. These oscillative transients are classified into three types based on the frequency variation. If the primary frequency component is less than 5 kilohertz, then it is known as low frequency transient. If the frequency component in between 5 kilohertz to 500 kilohertz, then it is known as a medium oscillatory transient. Third one is if the frequency component is greater than 500 kilohertz, then it is known as the high frequency transient. So these are the very classification of the transients based on the variation based on the frequency variation. Next, short duration voltage variation. So each type of the variation can be designated as instantaneous, momentary. Third one is the temporary, depending upon its duration. So these are classified into three types: interruption, sag, and swell. What are the main causes of this short duration voltage variations? Mean fault condition. Next one is the energization of large loads, which requires high sparking current. Next one is the intermittent loose connections in power wiring. So these are the major causes for the short duration voltage variation. Next, interruption. An interruption occurs when the supply voltage or load current decreases to less than 0.1 per unit for a period of time not exceeding 1 minute is called interruption. The main causes of this interruption is results of power system faults, equipment failure, and control malfunction. Next, swell. A swell is defined as an increase in the RMS voltage or current from 1.1 to 1.8 per unit at a rated power frequency for the duration from half cycle to 1 minute. So swells are usually characterized by their magnitude and duration. So these are subdivided into three categories, such as instantaneous. For example, if it exists in between 0.5 to 30 cycle, it is instantaneous. If the duration is 30 cycle to 3 seconds, then it is momentary. If it is 3 seconds to 1 minute, then it is temporary. Next one is long duration voltage variation. Long duration voltage variations are the root mean square deviations at the power frequencies for the longer than 1 minute. So it may be over voltage, under voltage, or sustained interruption. First, over voltage. Yes, over voltage means it is increase in the AC RMS voltage greater than 110% at the power frequency for a duration longer than 1 minute. The main causes of this over voltage are load switching. Example, switching off a large load or energizing a capacitor bank. Next one is the incorrect tap settings on the transformer can also result in the system over voltage. Yes. So what are the effect of this over voltage mean? The over voltages result because either the system is too weak for the desired voltage regulation or voltage controls are inadequate. So generally these over voltages and under voltages are generally not the result of the system faults, but are caused by the load variations on the system and the system switching operation. Next, under voltage. So under voltage means it is a decrease in the RMS AC voltage less than 90% at the power frequency for a duration longer than 1 minute. Example for this under voltage is load switching. Example, switching on a large load or overloading. Next one is due to the fault on the lines. So what are the causes for this under voltage means? A load switching on or a capacitor bank switching off can cause an under voltage until the voltage regulation equipment on the system can bring the voltage back to the within the tolerance. Overload circuit can result in the underload. Next, sustained interruption. When the supply voltage has been zero for a period of time in excess of 1 minute, then the long duration voltage variations may be considered as a sustained interruption. This term has been defined to be more specific regarding to the absence of voltage for a long periods. Causes of the sustained interruptions are the power system fault, equipment failures, and control malfunction. Next, voltage imbalance. So voltage imbalance is defined as the ratio of the negative or zero sequence component to the positive sequence component. So sources of this voltage imbalance are generally the results of unbalanced load. Single phase loads on the three phase circuit, it is a less than 2%. Result of failure in any one of the phase of the three phase capacitor bank. The severe voltage unbalance greater than 5% can result from the single phase condition. So this can be obtained. Voltage imbalance is equal to maximum deviation of average of the three phase voltage divided by average of three phase voltage into 100 will gives the voltage imbalance. Next, DC offset. The presence of a DC voltage or current in a AC power system is termed as DC offset. Next, harmonics. Harmonics are sinusoidal voltages or current having the frequencies that are integer multiples of the fundamental frequency at which the supply system is designed to operate. So these are the some of the power quality standards. So responsibilities of the suppliers of electric power, keep free from the harmonic, maintaining the record of classes, loads, analyze the node. Thank you.